Excellent. Snuggled by Ori today. Dude, I just finished my midterm. So I worked and then got out of my midterm. Just finished my midterm. And now it's raining. I was gonna go run outside. What am I gonna do? It's the return of Ruby's kinesiology talks. I've been meaning to do this one forever, but I'm busy. I do a lot of things. Let's see what the heck I'm doing. Okay, gotta make a graph. And like that. Can you even see that on the screen? Oh, kind of. Okay, not bad. Let's see if I can do this a little better. It's called production value. Look it up sometime. And then don't judge me on this because I know this isn't production value. Okay, anyway. Ruby's Kinesiology Talks, Episode 3. Today is a doozy. I'm going to talk about what I did for my undergraduate research thesis. It is a little wild. Oh, my cat's in here. Hold on. So basically, my research looked at, could you use exercise to moderate the screen time sleep interaction? Meaning, if you had a lot of screen time, which typically causes bad sleep, could you then exercise to have good sleep? And it's a good question. Okay, so first, some physiological premises here. And like the most kind of important thing when we talk about sleep is a little graph called the dual force sleep cycle graph, in which there's two forces that determine kind of when we're awake, when we're asleep, when we can fall asleep. So sometimes we lay down and we can't fall asleep, sometimes we lay down and we can. And this graph will largely explain why that is. So we've got here kind of a graph of time, and each of these chunks is kind of 12 hours. So the first force that we have is the circadian rhythm. It exhibits a wakefulness force. So in general, we tend to be not very awake in the morning. We tend to wake up throughout the day here. We're very, very awake at kind of noon. And then as the sun goes down, we become less awake, where we're very, very not awake at midnight. And then it progressively ramps up again. Noon the next day, night the next day, and it goes as a wave in this kind of 24-hour cycle. So this makes a lot of sense. Evolutionarily, it would be very advantageous for us to be awake during the day. That's when we would hunt and gather and navigate and do the things that are requisite to survival of the time. At nighttime, we wouldn't be able to see anything, so it would be an advantageous time for us to sleep. It's not very productive. So that's being awake. Now, being asleep or sleepiness is a separate force. Interestingly, it's not the same force. They're separate ones. And the sleep force is not a wave. It's kind of just a linear line. I actually think it's sigmoidal, but I don't remember. I did this a long time ago. But basically, if we wake up here, we'll say we wake up at 8 o'clock, and then as long as we're awake, this graph just keeps going up and up and up and up and up over time. So this is referred to as sleep pressure, the pressure of you to go to sleep. And the longer you're awake, the greater the sleep pressure goes up. Now, interesting point here is where this line intersects. So wakefulness then dips below sleepiness. So over here, wakefulness is the dominant force. You're more awake than you are asleep. Over here, sleepiness is the more dominant force. So you're more tired than you are awake. So basically, if you go to sleep or go to bed here, you're way more awake than you are asleep. You probably won't fall asleep. If you go to bed here, you're more tired than you are awake. You probably will fall asleep. Once you fall asleep, the sleep cycle drops back down as the pressure is released. And then when you wake up, it just continues on, hits that thing, drops down when you go to sleep. And that is the 24-hour cycle of us sleeping and awaking. Now, to my research. So this wakefulness graph here that goes in the 24-hour wave is predominantly determined by light exposure. So our eyes see light. Greater light tells us, hey, it's daytime. We need to be awake for this. and then low light tells us we don't need to be awake for that. So the light exposure, which typically would correlate with day, is high during the day, low during the night, and our body has built a rhythm around that. Now, in a sense, the peril of screen time is that light exposure is non-organic temporally. So it isn't your exposure to light is not necessarily linked to the times of day. A great example would be doing computer work after the sun goes down, playing video games at night, things like that. So what happens there is your body sees this light and it goes, oh, hey, you know what? I thought that was noon, but actually it looks like this is noon. And it shifts that whole graph a couple hours later in the day. And what happens then is even though the sleep pressure is going up at the same rate, that intersection is now later in the day, resulting in you falling asleep 2 to 3 hours later when your screen time exposure was kind of earlier in the day. So this is the peril of screen time in sleep. They have an inverse relationship: greater screen time, worse sleep; lower screen time, better sleep. Now, my research question was, hey, say you've already done that. Say you are a student or a professor, or you have some kind of job where you have unavoidable screen time and you've already right shifted your sleep schedule. What if you exercise during the day and you accelerate your tiredness, and then it continues to kind of go at its normal pace? So you accelerate up to there, it goes at its normal pace, and then they kind of cross over around the same time that it would have anyways. So basically you're using your exercise is like a sleeping pill to put you to sleep at the same time that you would biologically fall asleep without any influence, which would be what an amazing finding that would be. Because so much screen time in the world, it's largely unavoidable for everybody or for many professionals. So this would be a very significant finding. Now, is it what I found? No. So in general, the resultants are divided into 3 different populations. So the first population was people with concurrent mental illness that affected their sleep. So in my research, this was people with depression, anxiety disorders, post-traumatic stress disorder, acute stress response, these types of things. And that was just such a confounding variable that it just didn't differentiate in my research. So, and that's not to say exercise doesn't do great things for that population. I would argue it's the best thing for that population, but it just wasn't what I was measuring. So for that population, it just it did no moderative effect. The second population, and this is probably the most depressing finding of my work, was that it was people that are their sleep schedule is not directly linked to their biological drives. And so for this is people that like they sleep kind of according to their schedule as opposed to when they want to. So this is like maybe professors that are grading at night, or students that have to study late, shift workers, and interestingly, parents. So even though for them this crossover is kind of here at like 9 o'clock, they would love to go to bed at that time. For example, of the parents, instead of them going to bed, they put their kid to bed, they prep for the next day, they go to bed 2 or 3 hours later, and they wake up when their alarm goes off. So even though biologically their drive is saying, hey, go to bed at 9, they just schedule-wise can't. So in that population, this intervention did nothing. And again, lots of health benefits with exercise, just no sleep moderative effect. In the last population, the population that it actually worked in was people that could follow their biological drives to go to sleep. So in my research, this was homemakers and people that were job hunting. So these are people that are very, very busy. They have a lot to do, but it isn't scheduled at a specific time of day, so they can do it when they want to. And for them, we did see the relationship that higher screen time and higher exercise correlated to a kind of neutral sleep. Higher screen time, low exercise, bad sleep, etc. So for them, the findings did maintain, which was kind of interesting. Okay, now the rants begin on this. So the ultimate takeaway that I got from doing this research, which was like really hard and really complicated, was basically the takeaway of like, read the whole article. and one of the research supervisors actually talked to me about this, about how this is a great clinical finding, even though statistically it's not a very interesting finding. Because if you read the abstract, it's going to say, hey, look, this doesn't work. But if you read through the clinical findings, you'll say like, oh, okay, I'm in this population I'm a parent, it's not going to work for me. But if you go through a period of, say, unemployment, you can go, oh, maybe it will work now. And so that difference of statistical versus clinical significance was a really cool thing that I took away from this. Okay, that's the main one. Now to do some really interesting findings. I really enjoy making these, and like so many people message me and tell me how interesting these are. Hopefully they like this one, I don't know. Be a content creator someday. Someday. All right, bonus slice here. I'm going to talk about, because I researched sleep, and this was like a whole year of me just deep diving into sleep. I learned a lot about sleep and about the neurology and endocrinology of sleep. So I'm going to talk now about how our eyes perceive light, how their circadian rhythm is produced, and the science behind blue light filtering glasses. So, a bit of ocular anatomy here. So our eyes have these receptors at the end of neurons. Light hits them, turns the neuron on, which then goes to part of our brain and activates that part of our brain. These receptors in our eyes come in two types. There's rods and cones. Cones are shaped like a cone, and rods shaped like a rods. That's kind of where they get their name from. Now they have different functions. The rod responds to light presence, and its intensity. So if we have our rod here, and say one wave of light hits it, it pushes that rod in a little bit, and that tells our brain, hey, that's a dim light. And then if more light comes and hits it, pushes in it even more, our brain says, oh, hey, that's a brighter light, etc., etc. If we stare at the sun, it breaks this rod, and then we can't use that rod anymore. So some ocular damage occurs. Now, in addition to wave intensity, we want to know wave quality, because the different lengths of the wave determine light quality. And this is how our cones kind of perceive that. So if we have kind of a shorter or a kind of taller, slower wave here, it might kind of skip right over this wide and short rod or a cone. And so this won't turn on. However, it's very likely to hit this tall and skinny cone, which will then say, hey, that's red. So it's going to see red without turning on, say, the blue receptor. But if we have a skinny wave, it's likely to miss the skinny cone, and it's likely to hit the wide cone, which is then going to tell us, hey, that's blue. And so our cones kind of pick up the waves that they're designed for, and they paint the plethora of colors that we can see. Just like our primary colors that we learn, it creates all this infinite combination via the neural activation of those different cones. Now, I mentioned before that the circadian rhythm responds to light, and a lot of light keeps us awake. Low light, we don't really need to be awake for that. So if you would think, oh, hey, I need a receptor to respond to the presence and absence of light in order to wake me up. When you consider the anatomy, you would go, hey, like a rod seems like a good idea for that. But interestingly, it's actually a cone. Particularly, it's the blue light cone. And this makes sense like evolutionarily, right? Like the sky is blue. It's always been blue. It always will be. And so our brain picks up on that and says, that's the indicator that says it's daytime. And other lights that are non-blue, so like fire, is our brain goes, oh yeah, that's light, but that's not daytime. And so it can filter out circadian-wise when it's day and when it's not by the different light colors, which is really interesting. And this is where we see the disruption of circadian rhythms from screen time, because that blue light hits our eyes at non-organic times, and it tells our brain, hey, this is daytime, even though it's not. So when you filter that blue light, you can perceive that light outside of its organic times, so at nighttime, and it will have no or less effect on your circadian rhythm. So that's the idea behind blue light filters. And like, interestingly, this is kind of how bats work. If you ever go to the zoo and you see bats in the red light, it's because they don't have the red light cone. So for them, it's pitch black in there because they just don't have the anatomy to even pick up that wave. But for us, we can see them very clearly within that color, which is kind of interesting. Another interesting thing, and I should have said this earlier, is that this circadian light perception is what's called a non-photoptic receptor. So these ones that I pointed out that determine light intensity and light quality are photoptic receptor. So photo means it responds to light, and then optic means it creates an optical picture inside of our brain. So the light hits our eyes and we can perceive what we're looking at. We perceive the light that comes in. So this blue light circadian cone is non-photoptic. So the light hits it, and instead of going to the perception part of the brain, it goes to a different part of the brain and turns on and off our wakefulness. And so it's just kind of interesting that light and colors are coming into our eyes all the time, and yet we perceive only a portion of that. Pretty interesting. I think this is the rainiest year I've ever lived through. Look at all this rain. That's out of control. Okay, totally shot that piece in front of like the glass door of the dojo, and there's like coaches on the other side. Like, what is he doing? Oh, vlogging. How interesting. Oh, and the spoiler is that I'm just gonna lift weights and then go home and play some video games. No climb today. I'm too tired for it, I think. I don't think I would enjoy it. So instead, I'm gonna do the leg day. Where's the logic in that? What a day. What a day. Hello. I'm a vlogger, I swear. I'm professional. Man. Busy work day, busy work week. It's busy time right now. Good workout. Muay Thai tonight. Partners with Brandon. He's really nice. We did clenches, which was all right. And then jiu-jitsu. Okay, so jiu-jitsu tonight. We did choke escapes, and then we did turtle flips and ankle lock from bottom of back mount. And those are my signature moves, like the ankle lock on the bottom of back mount, particularly huge move of mine. But I was thinking about the turtle flip because the turtle, like knee wedge belt pull turtle flip is like really intuitive. And I always feel cheated by jiu-jitsu if the move is intuitive. It's like, that's what I would have done if I didn't know jiu-jitsu. So it's kind of funny. But yeah, man, it was kind of a busy class, partnered with Jeremy. It's good to see him back. And then back day today. I can't stop thinking about my week off. I got next week off. Can't stop thinking about it. Oh, also another dumb thing. Okay, so we'll see where this goes. So I was watching Instagram and there was this reel about a guy who was like, oh man, running a 6-minute mile is a great fitness test. And in my mind, running a 6-minute mile is not that hard. So 400 meters a track, you run that 4 times, takes about a minute each time. You know, that's very reasonable, I think. Like, it sounds really easy to me. But like, I don't pace myself, and I don't I don't know how fast I run. I feel like I run fast, but I don't know. And so I was talking to Brandon, and he's training for a half marathon, so he's like kind of timing how far it takes him to go places. So I was talking to him about like, hey, what's a 6-minute mile? And he was like, no, that's going to be really hard. So now it's in my head, and I'm like, I'm so certain that I could do this. So on my week off, that's like my one goal is I want to go try to run a 6-minute mile. Such a dumb thing, but I don't know.